Hello, welcome everybody. My name is Ted Stewart. Thank you so much for joining me today. Today's webinar is on the realistic failure rate data, and we're going to learn about all the different methods of an estimated approach, a predicted approach, and then, of course, the one that we are finding the most useful is the calibrated FMEDA method. And my name is Ted Stewart. If you can hear me okay, fantastic. If you can't, turn the volume up. We've already muted everyone's microphone to eliminate any kind of background noise. You'll notice there that there's a question toolbar. By all means, please ask away. And at the end of the presentation, I will answer them. If there's any that I cannot answer, of course, we have all the experts here in-house that I will get all the answers to. And then, of course, my ultimate goal is, besides getting you the presentation slides, having this call recorded so you can listen to it again, I will also attempt to put all the questions down from the first session and this session and write those up with the answers and send them all personally to you so that you have all the questions and all the answers written down somewhere as like a reference sheet. All right, let's go ahead and get started here. Thanks again for joining me. My name, like I said, I am Ted Stewart. If you don't know who I am or who exida is, I'll quickly go through some slides here, but I am the Program Development and Compliance Manager for exida. I have over 10 years of experience, which kind of includes automation systems, manufacturing, and lean process improvement. Quick background about myself. I started off at Lockheed Martin as a test engineer. I then moved over to Harris Corporation, where I basically worked for a group called Wireless Product Groups. We made little black boxes that could locate and track people. A lot of fun. And then I then moved over to exida, where I now get to manage the OEM certification division. I'm the director of the quality management system and the director of the CFSP program. So I get to wear a lot of different hats. It's a lot of fun. Every day I come into work, there's something new going on or some type of fire to put out, so to speak. Our company is very customer focused. We love to help our customers with the complete life cycle, whether you're dealing with alarm management, functional safety, cybersecurity, you name it, we can do it if it's in the process industry. I mean, it could even be consulting, certification, training, or even if you want to do the work yourself, we'll provide books and tools necessary to really help you. And when I first started working here at exida, I was one of those people that I want to do everything myself without those tools, because I felt like if I didn't use the tools, I could do more of a thorough job. And after a while, I realized I started checking my work with these tools because, here or there, I might make a small error. And speed up till today now, all I use is the tools because I realized, you can accelerate all your aspects of any type of project that you're working on. And now I spend most of my time helping develop new industry sectors like cybersecurity and even some other areas that I can't speak about yet because we haven't developed them, but a lot of cool stuff going on here at exida. Okay, so the slide in front of you, it's kind of like my story of how I arrived at exida. About 5 or 6 years ago, this company was presented in front of me by really my wife, Lauren Stewart. If you've listened to webinars before, you've probably listened to one that she's given. Long story short, she was consulting for exida, loved the company, so I started looking into it. I had my great job with a government contracting company, but this slide caught my eye. And of course, this slide wasn't created then, but the aspect of this company, one, you see the track record, right? So within a short 20 years or so, we've already taken over 2/3 of the safety device certification market. And the other part that really intrigued me about the company is that you have the opportunity when you work for exida for partial ownership. And that was kind of a no-brainer to me. So, when you're working for a large company like I was, you go to work, you leave work, you go to work, you leave work, and you kind of hope for those raises, you hope for salary increases. Here at exida, the harder we work, the harder we help our clients, our customers. As long as this company is doing good, we're doing great. And so it's been a fantastic ride so far. Anyways, as far as the expertise is to go, I think these numbers came from 2016 or 2017, but we've done over 1,000 certification assessment projects. We've modeled over 500,000 CIFs, and of course we have over 100 global experts around the world. Just so you can kind of see those little exida triangles, those are all our different locations around the world. Many people don't realize, but we do more than just certifications. Even some of our industries, we do automotive, power industry, robotics, alarm management, cybersecurity, It could be in oil, pulp and paper, refinery, chemical plants. I mean, the list goes on, and it's just a lot of fun. And I personally just get to touch a little bit of everything because I'm one of those guys that helps develop these sectors. So tools, like I said, the one for today that really will impact our discussion, so the one that actually reflects, is that SILSTAT. That's the field failure data collection software. That's the one that I'm still learning about. I've used it a few different times, and this is where you can calculate and get those realistic failure rate data, and at least know what you should be tracking and what data you should be entering to have a really good tracking system. But you know, there's many other tools, and every tool that is developed, it kind of becomes like a suite of products where you can start using in the life cycle. So because we're involved with that complete supply chain of functional safety and all these different sectors that we talked about, you know, we help the manufacturers who require that certification for their products. We help the end users who use that product. But it's really neat to see how these software tools are now that suite where for every step of the life cycle that you're going through, there's some type of tool that you can use to help you with the calculations to develop it, and it's really, really convenient, let's say. If you're one of those people who like to do things yourself, or if you're someone that wants to learn more about functional safety, and then after the slide, we'll jump right into today's presentation. But you know, if you are one of those people, you know, we have published a lot of books on almost anything that we know, and the reason why we like to publish books, one, it helps the marketplace. The more you know, the more the company knows, the people that we're helping, and they have this information, the stronger everyone becomes faster. We're always learning more. We're always trying to develop new topics. We're trying to develop new practices. But anytime that we run into somebody that doesn't know some information, doesn't really slow you down, but you'd rather them have the information right away. And that's why we publish things. Now we can say, hey, look in this chapter, and this is going to help you develop that SRS. Or, hey, look into this book here, and this will help you study for if you want to become your own expert. Say you want to be a CFSP, or you're going for cybersecurity, you want to be a CACE. Now we have things that you can do to do research on your own, and we're very proud of publishing all these different books. The most latest book we published actually was 2 weeks ago, I believe. It was by Chris O'Brien, Lauren Stewart, and Lindsay. That book in that top left-hand corner for Final Elements. A lot of good stuff in there. And we actually had some questions this morning in regards to that book because someone was talking about doing FMEDAs for valves and how do you make them stronger. Well, in that Final Elements books, we talk about a new topic of torque for valves, and very interesting stuff. So we're always trying to think outside the box. How do we improve the industry? How do we make things safer and more reliable? All right, I tend to talk fast, so I always try and slow myself down, and I apologize for that. So if you do have to listen to this on YouTube, just put me at half speed, and then I'll talk like a normal person. Okay, here we go. So let's start at the beginning when we talk about failure rate data sources, right? So what reliability engineers have known for decades is that if you want realistic failure information, it must ultimately come from one source, right? And that one source is really, you want quality field failure data for devices operating in a similar application. You're like, Ted, that's common sense, but it's really not that common. And you'll see why when I start going through some of these slides. It's so interesting how people gather failure information for things not applicable in your industry, but yet they're still using them because why? They have nothing else, or they don't know what else to use to generate these failure numbers. And the reason why even this webinar came up as a topic was because of this here in front of you. 61.5.11, the 2016 version, the new standard, came out with some heavy language, very strong language that, I mean, yes, sure, reliable engineers have known for and understood for a long time, but now it's finally somewhere that people have to follow. And it's not necessarily an easy task. And if you look at what you see in front of you, they use words like it has these. Once again, you say no kidding, but it's actually a lot harder when you try and figure this stuff out. But you need credible, traceable, documented, and justified information when you're trying to do your failure rate calculations. Might sound, yeah, well, of course you want something credible, of course you want something justified. But once you start diving into where this failure information is coming from, it becomes a little harder to meet these requirements. And so end users were starting to worry with what types of approaches can you use? Are you still able to use an FMEDA approach? You know, how do I comply to this standard? And so we'll go through that, and hopefully I can help answer some of your questions. Okay, so when you're gathering field failure data, there's two fundamental categories or techniques that you use to get this data. One, the estimation approach, right? This is kind of like your proven in use from your products. It's estimating your lambda based on the failure data. And the other part, right? What if you have a new product? How do you estimate failure data if it's a new product? It's not proven in use. Well, there's also things called prediction techniques, and they're based off of test results, based off of design strength analysis, and we'll go into each category. But first, let's talk about your estimation approaches. So how do we properly analyze these failure rates? You know, what is too low? What is too optimistic? What is pessimistic? And, you know, our founder, Dr. Goebel, he did say it best when, you know, when we were talking, he said, you know, math alone is not enough. And so I scratched my head. I said, look, if math alone is not enough, well, what else do you need? Isn't everything based off of statistics and analysis? Well, here's some bullet points in front to help prove his point, where he talks about, well, look, sure you have your statistics, you need those, but what about the equipment? How is it used in the operation? And, you know, there's different component failure modes. Does it fail safe, fail dangerous, fail undetected, detected? And then you have environmental conditions. Where are you using this? Is it in the desert? Is it in the jungle? You know, is it offshore, onshore? How is the equipment used? And then what about the data? How's that data that you have? How's it going to be used by those designers? Is it going to be used correctly? So all of these things now become a factor when you start developing these failure rates. There are three different areas, let's call them industries, not industries because that doesn't work, but really there's three different places where you can gather estimated field failure data. The first one is, of course, industry databases. This is something like ERIDA, right? You have that, it's great information. One thing that people need to realize though is with all of these different areas, there are pros and there's cons to all of them, good and bad, right? Industry, great information, great databases out there, like I already mentioned ERIDA. The thing you have to understand is, how do you use this great information? Because if you use it incorrectly, now the importance and the usefulness goes away. Let's talk about end user field failure data studies. Once again, one of the best sources, but hey, guess what? It's kind of hard to gather, and also now more so in the earlier days, because now end users are getting so much better, because I think it's becoming a realization that, hey, look, we really need to gather quality data and provide excellent site-specific data, because so many existing systems right now are weak. And they're gathering some information, but not all information, or they're gathering data to a certain depth, but not deep enough, right? They might say, hey, I've had 15 valves fail, but what type of valves were they? Were they gate valves, pilot valves? And so that's the level of detail we need to get down to, is really that manufacturing model and make of that product. So then we can fully understand what types are failing, if some are better than others. And that's just in due time. And there's some phenomenal end users out there that have some very, very nice return systems in place. And it's really, really helping our industry. Now we just have to play catch up with some others. Then you have manufacturing field return data studies. These are very useful, but you know what? They can also be very misleading as well, because as you know, these manufacturers don't understand. They do understand, but we can't predict the percentage of actual failures out there, because not everything gets returned to a manufacturer. It could be maybe 10%, maybe it's 30%, 50%, 70%. But one thing is also for sure is that when you talk to different people and different manufacturers, you know, everybody has a different definition for what a failure really is, and that creates this problem scenario, because now you're not doing apples to apples. And so you need to figure out and have some kind of standard as to what's a failure, what's not, what's random, what's systematic. And if we talk about random and systematic, everybody on this call here will probably have a different opinion on that as well. So it's not as easy as it sounds, but there are ways to get the job done. Let's talk about industry databases, right? Let's talk about the first one. We'll talk about each one briefly, and then we'll go into a predicted side. So however, you know, the thing with ERIDA, it's a great database. It's operated by DNV in Norway, the data analysis by Syntaf in Norway. This database provides high quality data on process equipment in generic categories. The caveat or the thing that you need to consider is when I say you need to learn how to use this information is the data doesn't go down to the instrument level. And because of that data, it actually starts becoming challenging to even meet the requirements of 61511 now. Why? Because you have to show justification, and that justification seems to disappear because now when they say, hey, what has failed? Show me proof. Well, all we can do with ARETA data is we can say, hey, well, we have this quick exhaust valve. Let me go to ARETA. Oh, wait, all that's in ARETA is valve assemblies. And valve assemblies, they contain solenoid valves, quick exhaust valves, rack and pinions, pinion actuator, butterfly valve. So all these different types of valves are now meshed together and called a valve assembly. So if you're trying to justify failure rates for just one of those, you really can't use that data anymore. And so that's one of the challenges now that we're starting to face. And that's why knowledge is power, right? So the more we tell people, the better these databases are going to get. And yeah, it becomes tricky. But we do have what we feel are the solutions, and that's what we're going to talk about. And so now let's move into the end users, because end users have the power. The end users are the ones that can develop this extremely high quality data collection and analysis systems. There's a lot that are already doing it, and there's probably a lot more that are not. Why is this? Well, maybe it's not something that's one of their priorities. There's so many companies out there that need to keep their plant running. They need to just keep moving. Maybe they don't have the personnel to keep track of these failures. When a company gets so big, you lose eyes, right? It's easy when you're small because it really hurts you. When you're big, you can just quickly exchange things out, keep moving on, not worry about doing the analysis of why that failed. Who cares? Do we need to ship it back now? Don't worry about it. Let's just buy a new one because it's faster just to throw a new one in than to try and go through a return policy that could take 4 to 6 months just to get a new one because we want to follow the right channel. So a lot of people just exchange them out. They never track their information. If they do track it, they might not go down to that. They might only do the assembly level. They might not go down to the device level. And, they might not collect all the failures. The operating conditions might not be recorded. And so there's a lot of things to be considered when tracking, let's just say, failures for end users. Now, like I said, and I'd say like a decade ago, almost nothing was being tracked, and now we're slowly seeing more and more tracking, and that's why we do these webinars so often. Is we're really just trying to get the word out there, hoping that you'll help carry this word to others to hopefully let's develop a better industry together, and that's our main purpose. Okay, now let's talk about manufacturer field return studies. This manufacturer data is very useful, but it can also be not so useful, right? And so from what I've seen is when manufacturer return information is used the most often, it's usually within companies that are doing self-declaration certificates or from certifying agencies that are really looking to get a competitive advantage on failure rates. Because what happens is it becomes very optimistic, and you get very optimistic failure return numbers. And why is that? It almost becomes obvious because not all those returns are, or not all those failures are coming back to the manufacturer, so they don't know about them. And if they don't know about them, they don't count them as failures. And a lot of the failures that come back, people say, oh, it's a systematic, or there was really no problem found. And if there's no analysis or justification as to why it's a systematic or why there's no problem found, guess what? You leave it out of the equation, and that product becomes that much more optimistic. And so these are some of the things that become concerns. Now, they're great when they come back. It's great to analyze what comes back. It's awesome to see manufacturers taking this data, performing impact analysis, improving their products, finding, and really creating a systematic, or really changing these systematic errors so that they go away, right? Because I always tell everybody, if you want to call it random, if you want to call it systematic, here's my challenge to you. You call everything random until you fix it. When you fix it and that problem goes away, now you can call it systematic. But until then, I say, look, it's random until you do something about it, because it's always going to happen until that company does something. And that's, when I've had conversations, that's what I tell them, whether they like it or not. It makes the most sense than just trying to argue going back and forth. At least now that you have something you can go by and say, look, if you're going to do something about it, awesome. I want to give you credit for that. Here's something that happened just last year. It's just an example. It's kind of fun, and this example is going to come back to you. So one example of a manufacturer, they supplied their failure rate calculations, right? We're not going to have any assumptions. This is going to be completely anonymous. And but what you're going to look here is that their predicted rates, you see here, it shows that a mean time before failure, right? You see all those years there, and then you see your fits. Well, what you're going to also look at, and look how low those failure rates are, right, with their estimation. If you look at the predicted side, the side that's not in that box, look how high those failure rates are. Right, look at the large difference between the two. And this is just what one manufacturer came to us saying, hey, here's our numbers. Don't they look good? And we'll go into that in more detail as we go through this presentation. Now, why does this topic come up more and more and more? And why are we talking about estimation and predicted failure rates? Because in the past, all we had were estimation rates. And guess what? It was a great approach. It worked. And it was perfect for the industry back then. However, because things are changing, because reliability is a huge concern for people, and people are taking quality serious, they're rapidly getting better, right? Products are now more reliable. The quality systems are so much better. And because of this, when you use an estimated approach, or when you use these lesser approaches, let's just call them, it was known that things were going to fail. So because things are going to fail all the time, yeah, it's common that you're going to have a lot of failures, and you don't really need to track them as important, right? And because the little quality field data out there, this was acceptable back then. And but things are starting to change, and by the time that people, when you use like this proven and use or estimated type of approach, products become obsolete. So when you're able to apply this estimation technique, those products tend to be obsolete already, and then you have to start all over again because new designs aren't covered anymore. And that's what makes things even more challenging. So when you go into now that, let's change gears and say, okay, let's talk about a prediction type approach, right? So now we know how to get estimated approaches, right? We can use end users, manufacturers, the databases out there. But now what about new products? What about how do we justify those numbers? Well, you need a different system to justify it with, and that's the predictive rate. So something needs to be better to help when you don't know what these failure rates could be. And there's three different approaches. The first one is the B10, right? That one used to be very popular. However, what people didn't realize, and still even to this day, some people still use B10 data for low demand applications. And that's a big no-no, because what B10 is it's basically a great technique for high demand and continuous applications. And this is like, basically B10 is all about wear out. It's cycle testing. You're going to keep using it over and over and over and over again until it finally fails. And the debate with those that believe in this message, they say, look, if you're going to use B10 data, it must be used when a product moves, let's just say 1 in 100 hours. And some even argue and say, no, that's even too less. You want to use B10 when it moves maybe 1 in every 10 hours. So it is a great technique, just not a low demand application. So you kind of want to move that one out right away if we're talking about the low demand industry. So now you have two others. You have the Mill Handbook 217 and the FMEDA approach. All right, and we're going to talk about both of those. So this one, the Mill Handbook 217, once again, the basic tells us that failure rates of a series of a system is the sum of all failure rates of those components. And this Mill Handbook 217 is a well accepted, it's been used for decades, but now we're starting to see some issues with this method. And from that example, actually, it's on my next slide here. We had an organization last year use the Mill Handbook 217 method, and it's starting to not make sense for them either. So what you'll see here is that the Mill Handbook, it's got two different methods. One is for your parts count method. It's real simple. You just add the lambdas of the parts from their data tables. You get a total, and that's it. And then you have the part stress method, where then you start throwing in, you adjust the lambdas for environments to add up to get your total. The thing that people are starting to realize, though, is that because products are getting better, these studies are now showing to be extremely pessimistic. And so pessimistic where we're seeing a 4x difference all the way up to a 20x difference. And that's kind of what I want to show here. Is this was, like I said, this was 2017. It was just last year. This is the data that we just gathered. This was a slide I previously had shown you. But when you look at the predicted MTBF, mean time before failure, and you look at the lambda of the fits, look when they said their estimated was at 1,237 fits, right, in that yellow box. But then when they did their mill handbook 217 calculation, 15,468. They came to saying, what's going on? Why are our predicted rates so high? And this is exactly why. It's because products are getting better, and the companies that are still using the mill handbook 217, in my personal opinion, is because these were implemented, let's say in the 1970s or so, or 1960s, 1980s. This was acceptable approach. There was really nothing else that they could use. But even just recently, we were just talking to a client, and he said, look, Ted, yeah, I know mill handbook is still in our procedures, but Ted, it's like getting something through Congress. We're a large company. It's so hard to make a change, so it's just going to sit in there. And I laughed, and it's true. It's unfortunately true. Maybe that's why I like working at Exits, because we can make changes all the time. But yeah, so that's why they're still in there. That's why companies are still using them. But we're just trying to let people know that, hey, there's better methods out there. One of those methods now that's becoming very well accepted is this FMEDA approach. What this approach does is it actually takes things like the mill handbook 217 and it takes other approaches. It adds in things like temperature, it adds in humidity, movement, vibration, all the different types of failure modes, diagnostic coverage. We use useful life, proof test coverage. All of these different factors are now becoming part of the calculation of an FMEDA, and that's why you get, let's just, if I could put parentheses, quotations, let's call it, quotations is better, realistic failure rates, right? So we're starting to see realistic failure rates from this approach, even though it's a predictive method, because of all these different elements that are being added in. Okay, so people say, look, Ted, you know, that's all well and good. I know that they're good. However, I've seen some pretty bad FMEDAs where they've come up with really unrealistic numbers. And I'm going to say you're 100% correct, because I've seen those too. Because what people are trying to do is they're going to say, look, all FMEDAs are equal, and they're really not. What it comes down to is what database are you using? Because what you put into this FMEDA is what you're going to get out of that FMEDA. And so when manufacturers are doing these calculations, or even end users are doing these calculations on their own, you need to start asking questions. Where do we get this data from? Was it from the right industry? Are we using the right stress factors? And because there's so many categories. I mean, we've even had an FMEDA come across, and we even have a certifying body, obviously not us, but one of our competitors, and they use a database where they got most of their failure rates from a washing machine industry. Pretty interesting, huh? I will not release that information. However, I will say it's out there. You're going to see a lot of optimistic certificates, and when you do, you need to start asking questions, because it's very dangerous. And there's now websites out there that will let you show you, okay, what is an acceptable range? And as long as that product falls within that range, you can give it a thumbs up and you can move forward and you don't have to worry about it. Even if you don't know anything about functional safety, if you see that this falls within that range, you're good to go. And there's a website, I can send it later, but it's called silsafedata.com. That's silsafedata.com. And you go on there, you can get the ranges so you can see what a typical valve, butterfly valve would be, and then you can, go through that. All right. So how do we overcome this problem? Because this was something that came up, and that's why this whole calibrating an FMEDA came about. So what this FMEDA does, and when you have a good one, is here's what really should be happening within that FMEDA to get this database to where it needs to be, is you have you have to produce these realistic results, right? So how do you do that with an FMEDA component database? Well, you always need to calibrate it, and you always need to validate it with actual data out there from those end users that are dealing in your same environment, dealing in your same application. So here's something that you can kind of see what you should expect or how you should compare something. You have the operational hours and you have the field return reports. That's the estimation side, right? They get their own field rate, and then you get lambda 1. This is very simplistic, and we'll go into a little more detail. Or I can even just do a different webinar on it. But then you have the predicted side, where you have your design parameters, you have your applications, your environments, like how it's going to be used, and then you get a predicted failure rate. When you get that rate, now you can say, okay, lambda 1 compared to lambda 2, how do we do? Okay, and then when you say how did we do, now you start comparing, because these two should match, and if one does not, then something is flawed, something is not right. And that's why you see in this chart here where one says 1237, the other one says 15,468, something is not right with the approach, right? And so you got to figure out, why is that? So the really neat thing about the Calibrated FMEDA, here's kind of like a cheat sheet how it all works, is you basically, or what we basically do is you have the manufacturer data, you have end users that are using their tools, right, like SILSTAT, you have ISPM, which is just, for everyone's knowledge here, just another type of tool that people use, and then you have industry databases like ARITA, right? You put all these things together, and then you start getting published Lambda data, you get your field data from your end users and your manufacturers, and you compare everything together, right? So now we're in the middle. Let me get a cursor here. Hopefully you guys can see a cursor. All right, so you get this box here. Now everyone's comparing the data in this box. Then all of a sudden, from the data that you compare, you can update the component failures with what you're getting from the industry. From that, you can create new parts because of the FMEDA. I'm so sorry, I kind of skipped that. But this is what the industry is doing, and here's what your predicted approach is doing. So when you update your database, you're now using those updated numbers in your FMEDA. You then can create your new parts from the different components that are updated. You update the database here, and you keep cycling, right? You got to keep cycling until everything starts lining up and everything looks correct. And when you do, now all of a sudden you have realistic failure rates. So when you do your FMEDAs, they're now matching what's really happening in the industry. And that's where, oh, there it is in the yellow box there. Cell-safe data comes into play. When you look at a manufacturer's or somebody's failure rates, you can now quickly go to the site, see if they're within limit. If they're in limit, give that thumbs up, and let's keep moving. You don't have to ask any more questions. If they don't line up, that's when questions need to be asked. We've even made a kind of like a cheat sheet with, okay, here you go, end user. If you want to challenge a manufacturer's failure rate numbers because they're not within range, here are a couple questions for you to ask. And it's just helpful because the industry is moving so quickly. Anything we can do to help, we always get the information out there as fast as we can. So people ask us, well, how good is your database, and how are you doing your FMEDAs? How are you calibrating this information? Well, luckily for us, we started this a long time ago. And because we started it so long ago, we have, I think it's actually closer to 500 billion unit operating hours. Don't quote me on that. We can just say 350 plus for now. But we have so much information out there, and we get so much information. Why? Because this is one of the areas we spend the most time and effort in. Most of our research money goes into failure rates because we feel like that's the backbone of the industry. If you don't have good failure rates, you really have nothing going for you. And so we meet with Dow in the Netherlands on multiple different occasions. We've actually went through the ARITA database with a fine-tooth comb to make sure that all the numbers in there are comparable to ours. We'll look at all the manufacturer field return data studies, and I'll share with you a little insider of what we look for when we talk to manufacturers. So we do our due diligence, we have all these hours, and we're constantly updating and calibrating, because guess what? When products get better, those failure rates get better, and you'll actually see them on when we do our recertifications for companies that have been certified before. Those failure rates start looking better and better unless that industry is not doing as good, and then they go the other way. But what we're commonly seeing is that the failure rates are getting better. Companies are creating better, more reliable products, and it's really, really neat to see. Now, when we compare the FMEDA, from 35 different pressure transmitters, right? And we compare it with exida, we compare it with Dow. Here's what you will see. And here's like an average of all the blue dots are just different FMEDAs that we've done for different clients for just the pressure transmitters. We threw 35 of them out there. And what you'll see is, on average, because why you see the variance in there is because guess what? Everyone's pressure transmitter isn't made as good as the other person. There are better pressure transmitters out there, right? And so that's why you see the flux. But if you go on average for an FMEDA, that's where that middle dot, us, is going to sit. Where's my cursor? There it is. If you see Dow, they're a little bit to the right and a little bit lower, and then of course exida. So if you look about it, we're right there with what the industry is saying should be at. And yeah, if anything, we're slightly pessimistic, but I'd rather be pessimistic than optimistic because I'd rather you safer than sorry. And then this was after 15 years of comparisons. This is us constantly calibrating our FMEDAs to get that quite realistic approach that is what exida, it's what Dow, it's what the estimated databases are actually showing in the industry. All right, so now when I told you about comparing with manufacturer data, here's what we look for when going into, let's say, when we're talking to a manufacturer. The first thing you do when you're talking to the certification client is you ask for the shipping rates or shipping records and the return information. The one thing that needs to be noted is that you need to calculate or categorize these returns into failures, right? Not, you don't say, hey, this is a failure, but you want to categorize returns into failure categories. And the next slide, I'll show you why we do that. And then another thing you want to take note of is when a manufacturer sells something, they sell it, we say that there's a 6-month window after something ships that product will actually be used in some type of startup assumption, right? So that's a factor. Then we also say we need to choose a return rate assumption. Are 10% coming back, or 50, or 70? And these are the 3 typical ones that we end up using. And why is it not 100? Because we all know manufacturers don't get everything back, right? And if anything, even 70% is hard to obtain unless there's a really nice warranty plan in place for those customers so they can easily make returns and get things back. But what we really see is it's more like the 10 to 50% areas are what we are seeing. And so, because anytime you got a return and a customer returning something, that manufacturer, they don't actually make money, right? So manufacturers don't really want things to come back to them. And so that makes sense as well. So now the next thing we do is we use our exida spreadsheet. We calculate and estimate the total failure rate with about a 70 to 90% confidence factor for those failure rates. And then what happens is an upper and a lower bound are formed. And that's what you see in that yellow, the top and bottom dot. That is your upper and lower bound with the 90% confidence interval right there. And then, of course, when you're doing your FMEDA, this is where you then compare their warranty information to that FMEDA to make sure that that FMEDA falls within the range of the upper bound and the lower bound. So there's a lot of work that goes into just even when you do an FMEDA, there's so many other things that you have to calibrate, and there's so many other things that you have to compare it to make sure that those numbers are coming out like they should. Here's an example of a logic solver that we recently certified. It was a high power SIL 3. If you look at the shipping records, the operating hours, and the failure reports, I mean, look at how many operating hours that they've used, and you'll see that. I mean, it's, what is that? That's 8 million in 2015. You know, 4.5 million, 6 million, all the way up to 2017. Here's something interesting to note, though, is when they sent us all the failures, like, hey, look, you know, we had 188 failures. Well, because they were able to categorize their failures, we went through there and said, oh, actually, no, you don't have 188 failures. You actually have 100 failures. And we were able to discount many of those failures because from the reports and from the numbers that we saw, they were more systematic. They were not something of random failures, and because you only want to count those random failures. Now, the next thing here is, okay, so now let me go back. So if you see all these, you see 100 failures. Now what you do is you take that data and you put that into the spreadsheet here. The number of failures was 100. That's what was reported. You looked at all the warranty hours. So we got, 116 million. That's the number of devices times the number of days times, 24 hours in a day. That's how you get the warranty hours. Then you do the how many reports. This company was a very well-established company, so they said about 70% of the returns came back. It was an expensive device, so many people wanted to return them because they were very expensive. You look here, the complexity factor was a 1, and then as you go through, that's how your upper and your lower bounds were generated. And now you can see for this FMEDA data, 2,289 fits compared to 1,287 fits with that 70% factor. And that's how we do our calculations. And, because when people ask us, well, how are you coming up with these numbers? How do you justify? Well, now we have things that we can do to provide that information. So now let's go back to the standard. When we talk about how do we calibrate, how do we meet 61508, right? So how do we meet 61511 is if it's creditable. How do we justify that? Well, we say, look, it's publicly available. There's detailed descriptions of the method, and the results are within a failure of 90% confidence limit. The next thing we do is we look at the traceability. Are there records? Are they kept? Where are those records at? How is the data used? Where are the calculations done? And with all these different points, we've actually started making white papers to help justify that we meet 61511 in 2016, because a lot of discussions that we have, and actually I see a question or two in here, is, well, how do you provide evidence that you meet 61511? How are you credible? How are you traceable? How are you documented and justified? Well, this is exactly how we can meet that, right? Because we're showing this, even documented. Now we have a publicly available component database, right? So we even give people the data where they can purchase the database, but that information now is public as well. So that's one of the other things. And then, of course, finally, justification. Well, if you compare the predicted results with any industry-specific field data out there, you now can show that, hey, these FMEDAs are coming in right where the estimated approaches are, and you can provide that proof. And so I hope that makes sense, because that's one of those questions, and that's one of the reasons why this question keeps coming up, is because people are trying to figure out, well, how am I going to meet this standard? So in conclusion, and then, I'll get to some of these questions here. The main things that you want to take from this webinar is that there's estimation techniques in the automation device arena, but due to the lack of data and how they're grouping these categories, right? Like they're just doing valve assembly. There are things that are not working for the estimated approach, and plus there's lag time that products are going obsolete, and so when you calculate enough data, that products might not be even used in that industry anymore. The next thing is, because of the lack of this failure data, it can be a huge impediment to the implementation of 61511. That's why people are now looking at other techniques other than the estimation technique. And really, to summarize the rest of these points, the main objective is, look, the predictive approach alone is not enough. You can't just have one. You have to use both, right? You have to use a combination. That's why the FMEDA approach has been one of the most successful approaches, because you're doing an estimated compared to your predicted, and because you're using both of them, now you have something that's becoming realistic. Real quick, and then I'm going to answer all the questions. If you're looking, here's our Exit Academy. We have some fantastic trainings in functional safety, cybersecurity, alarm management, burner management as well for fire and gas. I take this slide for granted. I don't know if anyone else does. This is something that we give away so many free things, whether it's a webinar, blog, white papers. So if you want to at least get all the free stuff, join one of these things, because you'll probably end up getting it. LinkedIn is my favorite. If you want to add me, I'm always trying to help people and get more information out there. If you have questions, I'd like to get you the answers, and I can make you the expert. You can find me. There's a picture of me, so you know which Ted Stewart to click on. So now let's get to these questions here. All right, let me see if I can help answer some. The first one is, what does FIT stand for? Don't be sorry. FIT basically means failure in time. right? So that's all it really means is how many failures in a certain period of time, right? And so that's a good question. The next one is, what difference SIL level is the data acceptable? Well, really, you're going to have your fits, right? So each SIL level is some order of magnitude. The real question is that there's 3 obstacles that you're going to have to overcome if you want to achieve a SIL level, right? So you're going to have systematic. You need your random side, which is your failure rates, and then you're also going to need your architecture constraints, like your hardware fault tolerance. So those are the 3 things if you want to specify a SIL. Another question I have here is, am I able to purchase any of the books? Well, yeah. What can I show you? Here, real quickly. Let's just do this live here. If you go to Exida, just go to the store. Hopefully you can see what I'm doing here. And then you click on books. Hopefully that was easy enough. But here's where all the books are located. So if you need something, like I said, this one is our newest one, the Final Elements book. That's the one that, because we had a question from this morning and they were talking about, well, this is great, but how do you get a better FMEDA for a valve? Because that's our weakest link. And yeah, Final Elements are your weakest link. It's because those do fail. And it's kind of interesting that, you don't need a better FMEDA, or that technique doesn't need to be better. It's really, you need a better product. And right now we even accept, well, I don't accept, but where end users even accept that valve's leaking, it's okay. No, how do we solve a leaking valve? And right now, with a lot of pressure, maybe it's not possible. So we're even diving into even torque specs, and this book actually talks about different torque specs, and really starting to analyze and try and make the Final Elements not your weakest link anymore. Of course, that's an uphill battle, but it's fun trying to solve these types of these things that we're seeing, if that makes sense. So good question. Another question. Is the PowerPoint slides available? Yes, the PowerPoint slides will be available. I believe our marketing team will send those out probably tomorrow. They usually get them out tomorrow. And then for all these questions and all these answers, that'll probably be sometime next week, because I personally have to do that. And I might do some of it. I always do some over the weekend, and then I'll send them on out early next week. And can we have access to the failure rate books? You can. You're going to have to purchase it if you'd like to. Carolina, why don't you go ahead and, do I have my email? Yeah. Check out that email in front of you, or even if you'd rather send me something on LinkedIn, feel free, and I'll get you all that information that you'd like. No problem at all. I'd be more than happy to help you out. Yeah, of course, no problem. Any other questions? That's all I have in front of me. This has been a lot of fun for me. Hopefully I didn't talk too fast. Hopefully I gave you some good information. I really appreciate it. I'll wait another minute here, or 30 seconds. Oh, and if there's any other topics, I didn't even ask about that. Please, if you guys have questions and there's something that's always been bugging you, or you have a customer that says, I wish I had this answer, and you'd like a webinar on it, yeah, right there. Send it to academy@exida.com. We have someone that started with us maybe like a year ago now, Jatana Wasserman. She is incredible. And so she keeps everything locked up for us. She gives us all the new topics. We try and answer as many of them as we can, but she's a phenomenal person, and she's really, really helped us a lot. She's the one that works behind the scene, and it's fantastic. Her and Rick Smith. Got to give Rick Smith a shout out too. Okay, no more questions. You guys have been fantastic. Thank you so much. I appreciate your time. Have a great rest of the day, and hopefully you hear from me again. Take care for now. Bye-bye.